right, let's talk about scatter plots and lines of best fit. So, use the following table of values to create a scatter plot. Here's what a scatter plot is. It's just going to be a whole bunch of data points plotted in a graph. So if I take all these points and plot them, what I'll have is a scatter plot. So, -3, -2, go to the left 3, down 2. That's a point. -2, -1, left 2, down 1. 0, 1. Don't go left and right, go up 1. 1, 2, over 1, up 2. -1, 4, left 1, up 4. 2, 5, over 2, up 5. 1, 6, over 1, up 6. So I'm not going to connect the dots. It's just a whole bunch of points. They usually are not going to line up in any way. It's just like kind of what it sounds, a scatter plot. So a whole bunch of points that are scattered around. What we're going to do, though, is we're going to use our scatter plot to draw a line of best fit and come up with the equation of that line. So what we want to do is we want to find a line that best represents this data. So when I look at it, it looks like the data is kind of going upwards and heading this direction. It's not really looking like it's coming down. It's not really going flat. It's kind of going upwards in this direction. So if I could find a line, just one line to best kind of cut through right through the middle of this data, it would kind of go this direction. So we want a line that kind of fits in the middle so that when I make my line, the same amount of points is on top as there are on bottom. That's the goal. You won't always get it perfectly right. The idea is to try and get as close as possible. Now, the way I do this is I like to just pick 2 points for my line that I feel like are right in the middle. Now, the points that you pick, they could be one of your scatter plot points, or they might not. So what if I pick this line or this point right here? So I'm going to use a red X to symbolize, hey, this line of best fit I'm about to make. It's not any of my points, but it's kind of in between these 2 points and these 2 points. And I'm thinking my line's going to go this way. And I'm going to use this other point, which is actually one of the points of my scatter plot, which is fine. So you can use your scatter plot points. You don't need to. It doesn't matter. What we want is a line that tries to go right down the middle of our data and kind of fits the overall trend. So if I look at my 2 red X's and I use a straight edge to line these up and draw my line, this is what I believe is my line of best fit. Now notice I have 1 point above the line, another point above the line, another point above the line, and then 1 below, 2 below, 3 below. So there's 3 lines, 3 points above the line, 3 points below the line, and 1 point on the line. That's what we want. So we want to fit the overall trend of the data, which is going upwards, and we want it right in the middle. So having this line right down the middle is good. You wouldn't want to line up here, then everything's below. You wouldn't want it here because everything's above it. You want to go right down the middle. What we're going to do next is we're going to use our scatter plot, and we're going to come up with the equation of that line. So what I'm wanting to do is come up with the equation. Let's use what we know, which is y equals mx plus b. Where remember, m is our slope, and b is our y-intercept. So kind of looking at this, to get my slope, remember slope is rise over run. So I want to count how many do I go up and over, or it would be negative if I went down and over. This line's going in a positive direction, so I know it's positive. Let's count how many from red X to red X, how many do I go up and over? So I went up 1, 2, 3, 4, 5. So 5 over 1, 2, 3. So counting my slope, I rise 5, run 3. And I just went from red X to red X. So my slope is 5 over 3. My y-intercept, I want to look and see where do I cross the y-axis. It looks like we cross right at positive 2. So y equals 5 over 3x plus 2. One thing you want to be careful about is make sure your fraction is reduced if possible. So I have 5 over 3. That's not going to reduce. If I would have had like 6 over 3, 6 divided by 3 is positive 2. So always look to see if you can simplify that fraction if possible. Finally, we're going to use our equation, and we're going to predict y when x equals 7. So I have this equation. They give us this piece of information, x equals 7. They want to know y. So what I'm going to do is I'm going to take x equals 7 and plug it in right there. So I have y equals 5 over 3. Instead of x, let's plug in 7, so parentheses 7 plus 2. And I'm going to take a calculator, I'm going to type this all in. So here we go. 5 divided by 3, parentheses 7 plus 2. So I get y equals 13.666. So we could put that. If I wanted the decimal answer, or sorry, that's the decimal answer. If I wanted the fraction answer, math, frac, enter 41 over 3. Both of those would be correct. It kind of depends on what you're working with. I mean, if we're dealing with money or something like that, $13.66 is a lot better to say than 41 over $3 because not many people will know what 41 over 3 is. So it kind of depends on what you're dealing with what answer you want to put. Both of those are fine for right now. So that's just a basic scatter plot. I'm actually going to show a real example, a little bit more real data that we work with. So the following scatter plot of data shows the savings Y in dollars. So I know my y-axis represents dollars over time x in months. So I know my x is months. What we need to do is we need to draw and write the equation for the line of best fit. Okay, so I need to find, it looks like it's overall going downwards. I need to find an equation that fits there. So I'm going to draw two x's. I like this point, it would be kind of in the middle, and that point would be kind of in the middle. So I used 2 points that are actually already on my scatter plot. That's fine, I didn't need to. If I use my straight edge here and line them up, that would be my equation. So I have a point below, point above, and it looks like 4 points really, really close to the line. So that's a pretty good line. So what I need to come up with is the equation here, which is y equals mx plus b. So again, slope is rise over run. I need to count how many am I going. Well, it looks like we're going down and going over, so I know it's going to be negative because it's coming down. But we got to be careful here. I'm not just going down 1, 2, and then over 1, 2, 3, 4. Because if you notice, look at what our axes are labeled. So you might need to pay attention to that. So this goes 0, 8, 16. So between 0 and 8, this would be 4. Between 8 and 16, that would be 12. So it goes up by 4s. 4, 8, 12, 16, 20. And that would be 24 up there. And let's count now. Be very, very careful with the counting. So if I'm going down by 4, 8. So negative, and I'm going to have an 8. And then when we're running, I see 0, 2, 4, 6. So this is 1, 3, 5. So I go over 1, 2, 3, 4. So negative 8 over 4x. Just have to find a y-intercept, which it's between 20 and 24. To me, that looks like about positive 22. As always, try and simplify this fraction if you can. Negative 8 divided by 4 is going to be negative 2x plus 22. So try and simplify if you can. And there we are. One last follow-up question says, use your equation, predict your savings over 8 months. So this 8 months. Well, if we look up at the top, it doesn't really tell us if that's x or y, but we're talking about months, which is x. So what they really gave us is, hey, x equals 8. They want to know about savings, which we saw up top is y. So let's take 8, plug it in, and see what happens. So y equals negative 2, parentheses 8, plus 22. If you plug that in your calculator, you're going to get y equals 6. That was scatter plots and finding the line of best fit.